Hello there and welcome back to another session of object-oriented programming. And in this video I'm going to show you how you can implement the so-called monostate or Borg pattern in Python. This is a very interesting pattern because if you are familiar with the singleton instance and the pattern, then you know that in that case we want to make sure that there is only one instance available, and if that instance is not yet created, in case of singleton implementation, then that instance is created and it's returned to the caller. But if that instance already exists, then what it does is just simply returns the instance, so no new instance is created. So basically this way you ensure that there is only one instance at a time of execution. In the monostate pattern you have something similar going on, but similar in a very different way, because in case of a monostate pattern you have the internal state which is shared across all of the instances, and you can create any how and any much instances that you would like, and they will all have the same internal state. So how do we implement it in Python? That's why we are here, to find it out. So yeah, our first class of monostate is going to come from the object. Let's highlight it with this Python syntax, and we will call it internal state, which is the A variable with the value 5, the B variable with the value 6, and so on, or you could give it whatever kind of values you would like. So basically the point here is to provide consistent internal state for every object, for every instance of this object that is created, and this should be consistent. So what we are going to do is initialize this object, the sub, and all that needs to be done is the self dict equals self internal state, and basically this is how you create your monostate pattern. And let's demonstrate it. A equals monostate, B equals monostate, and A dot x equals 10, B dot x equals 20, and we will say the A object the B object and A object state, and we could call the dict here and here. Let's just save it here. Monostate.py. Let's open a command line. And if we look at this, what's happening here? So, as you can see, we have instantiated the object A and the B from the Monostate class. And what I did was assign the X property of the A, which did not exist at the time of the instantiation, the value 10. This is okay in a sense that it's not forbidden, but it's called monkey patching when you create a property on the fly and assign a value to it. So then I have created the X property of the B variable. I have printed the object A and the object B. We can see here they have different IDs. They are from the Monostate class, and here comes the fun part, because as you can see, the object's internal state, which should hold the A and the B value, also holds the X value, and the X value of the 20, which was the last assigned. Basically, this is how you can create the monostate, and there is another way to implement it, and I'm going to show you how you can do it. Yeah. Monostate v2. This is also coming from an object. This will also have an internal state, which is just simply going to be a dictionary, like the way before, without any values. And this time we will use the new constructor with the args and the keyword args arguments. And what we are going to do is say that we will have an object which is the super of the Monostate v2 class, and the class variable. Let's call the new function with the CLS args and the keyword args. And we are going to do is return this object. This is a bit more Pythonic way, but let's take a look at it in action. So CLS as you can see, this is almost identical. It's just the source code that is different, but the basic idea that it wants to represent is that this is the way the monostate pattern can and should be implemented in Python. And as we can see here, we did not have any initialized variables in the internal state, so that part was empty until we have monkey patched these objects with the X variable, and after that the latest assigned value of 20 is the value which is consistent across every instance of this class. But can we dig deeper? How about we print the ID of A.x and the B.x? what can we see? And yeah, basically, since you have this shared internal state, then you have the ID matching in case of every single instance. So this is why when you modify the x property of the a variable, then you modify basically every instance's x variable or property, because they are pointing to the same IDs, the same memory place. And that's why you can keep the consistent internal state of this pattern and the classes. So basically this is what I wanted to show you. I would like to thank you for watching. Give it a thumbs up if you liked it, and as always, the source code is going to be on GitHub. Thank you for watching. Bye.